All right, thank you guys. Glad to be here. First, I'm going to start with a disclaimer. I've sat through a whole bunch of wonderful presentations with a ton of technical content and just really good presentations all around. This is probably not going to be one of those. It has little to no technical content, but hopefully you'll enjoy it. I'm taking a look at our process towards coming up with a code for formwork for concrete, kind of drawing parallels to 2001: A Space Odyssey. So I was really glad to see a reference to another, Yoda. Now we got 2001: A Space Odyssey. Is anyone familiar with this movie or book? Okay, good. Otherwise, these things are going to be just really obscure. So here we are, dawn of formwork design. Cue the timpanis. This is the iconic first scene of the movie. Where the monolith drops down from the skies and just lands in the desert, and all the hominins were excited by it, and their first contact with this alien entity, right? Well, the 347 committee, we were organized in 1955. The initial progress with this committee was fast and furious. They initially developed a report in 1961. They had organized the committee with the goal of developing a specification for the design and construction of formwork. Like, that was the initial charge. Shortly thereafter, in 1963, they had developed the SP4, which is the Green Book, the Green Bible. This is the formwork Bible. It was first published in 1963. And, I would say that's an epic leap forward in formwork design. That was, huge. And then shortly thereafter, just a couple of years thereafter, 347 Guide was first published. So 4 years, got to the formwork guide. So things have changed since 1965. A lot of different forming and shoring products have developed over this time, a lot of different methods and means of building structures. So there's a variety of different materials, not just wood, although wood's very prominent, but wood, steel, aluminum, plastics. I wrote down a whole bunch of things here. So, aluminum fabrications, steel fabrications, extrusions, cast materials, roll threaded items, wooden timber structures, fiberglass, plastic structural parts, lost embedded items, plastic facing products, plywood products. The list goes on and on. There's lots of different things. So all these system formworks started to develop, and they've been designed in numerous countries using all sorts of different standards, nothing really condensing this all into one. And then there's also within formwork design, there's a wide variety of usages of all these products. There's the single pour, you set it up once, you pour it, you tear it down. But there's job-built forms, there's mechanized systems that use multiple times that have mechanisms that move it from place to place. There's a myriad of different options there to support the myriad of different ways that we construct buildings. And you can see here, this is, again, each one of my slides is going to have a little reference to 2001: A Space Odyssey. So, the scene in the movie is they have their first tool, which is the bone that they use to beat their enemies. Well, now the bone gets thrown up in the air and it transforms into a space station. While here we're transforming into a taper tie, just kind of showing that progress of we've gone from the Stone Age to now something that's consistent with how we actually use formwork today. So here's our path to a specification. Right around 2001, the 347 committee began outlining a formwork specification and started putting together just a outline of what we thought this was going to look like. Then by the fall of 2009, we finally took a vote to request to develop this specification. It was approved by TAC in 2010, so that 9-year period, not a lot of progress in there. There's probably draft copies and things. This was before my time in involvement with the committee. But, the other funny parallel there is, we started this in 2001, so that was kind of the initial thought with this was kind of fun. And then just coincidentally, we got approved to go forward by TAC, the mothership. They said go forward into 2010, which happens to be the sequel to the 2001: A Space Odyssey is 2010, the year we make contact of all things. So it just writes themselves. So, and then the third movie in this trilogy is 2061 Odyssey 3. And Rick, I think we can confidently say that we're on schedule to beat 2061. So, God willing, we're going to make that happen. Next reference here is, I said, Through the Stargate. If you recognize this part of the film, it's just this overwhelming thing where they're, the psychedelic images and all this craziness going on as they're flying through this time portal. So the quote from the movie is, this is kind of paraphrased from the quote from the movie, but this is kind of what I would say in reference to our work as a committee. We're putting ourselves to the fullest possible use, which is all that I think any committee can ever hope to do. It's just kind of a play on one of the quotes from the movies. So our committee is, we have a large group of wonderful professionals. We have 28 voting members, 6 consulting members, and 45 associate members. A lot of good involvement. We hold meetings Saturdays and Sundays each convention and get some good involvement each time. It's always great to see people show up, put in the time and work on these things. Along with that, we include 14 ACI fellows and 3 honorary members, some real distinguished folks. So our document, we've now collected this document, we've drafted the whole thing. We balloted the entire document in 4 groups. With those 4 groups, we had 964 comments received. I don't know how many of those were mine, but a good number. It was an overwhelming process, but we've resolved all those comments and submitted that back to TAC. It was, kind of mid last year, August of last year. And we did get that returned back to us. 3R returned, which we were expecting. It was the first time we were putting together a specification. 173 comments that we're currently working our way through. Our hope and expectation is to get that resolved within, say, a year from now and get it back to TAC's hands and see where it goes. So next reference here is the I'm sorry, I'm afraid I can't do that, is the quote from the sentient AI being that's guiding the ship. So just like interfacing with AI, language, context, syntax, all those things matter. And like I said, I'm focusing a lot more on the process than the actual content of our code. But I just think this was just kind of a fun parallel. We had to be very cognizant of all the using words like should versus shall in certain areas. It was very eye-opening and fun for me. I enjoyed that. So our code will be not a cookbook of how to. The code is written as what the user must do. So commentary will provide that context. The guide's going to be more background, and SP4 can remain to be that how-to, the overall how-to design formwork. And then another point that I wanted to point out was the definitions matter. In our industry, there's a lot of vernacular that you just talk and you get things thrown around, and you don't always get always the right meaning out of all the words. So examples would be like somebody says this has a 2,000 pound capacity. Well, what does that mean? Is that a LRFD capacity where you've multiplied by a resistance factor, or is that a allowable capacity where you've divided by a safety factor? And many of the documents that are out there are listed just as such. They don't provide that context. So, words like capacity, strength, safe working load, load limit, sometimes they can be ambiguous or misused. So our code's using things like nominal strength, available strength, design strength, allowable strength. So this one here is kind of an homage to David Johnson. David is a wonderful member of our committee. He's an honorary ACI member, and he's an editor and curator of SP4. Ton of work there. It's a huge document if you guys have ever seen it. It's a great one for us. Longtime committee member. My joke here is we'd always joke around whenever we finally got to quorum on, say, a Saturday, just got enough people in there that we could vote. Everybody joke about locking the doors. Well, David, unlike the computer being in the movie that locks them out of the ship to, basically get rid of the rest of the crew, David never actually locked us in a room when we got to quorum. And then also as the computer was controlling the ship, David providing that editorial hand throughout our document. He's guiding this whole thing. Compiled ballot documents, employed all the resolutions. He did a ton of work. And then we get to this. If you're familiar with this little scene, this is the part of the movie where I'm just like, what does this even mean? I have no idea what's going on. So in code writing, we got to remove ambiguity. We got to, some of the things that we've added into our document is adding like the responsibility of communication. We're saying, what is the formwork designer supposed to communicate to the contractor? What does the contractor have to communicate to the formwork designer? So formwork loads that are resolved into the permanent structure, those things have to be provided by the formwork designer so that the contractor knows what loads are getting put into the permanent structure. Operational procedures, that kind of thing, are all going to be in the code to say that must be specified. It also provides dividing lines, so lifting, rigging, those types of things are involved in the safe handling of formwork components. So there's a dividing line between when is it formwork, when is it rigging. Those types of things need to be delineated. Same thing with safe access. So when I'm accessing formwork, that you're working off of a work platform. Well, that work platform at some point becomes formwork. Where is that point? There are other codes out there that don't delineate that well, so we're trying to get that introduced into our document. There's a variety of load sources on temporary structures, dead, live, environmental loads, and things that are in temporary conditions that aren't even the final condition where they get loaded by some of these. They're in conditions where maybe they have to support their dead weight for a temporary time that's different than when it has to support the fresh concrete weight. So there's a lot of things that need to be communicated when you design formwork. And so, yeah, the last thing there was just what loads are appropriate for temporary work. Wind load is the one that comes to mind there. The environmental loads for something that's only there for a portion of time is not necessary to design to full design wind loads. Okay, so what's the future hold? So we've got a few main documents. I didn't list all the documents that our committee is involved with, but the ones that are related directly to kind of formwork design. We have the 347 guide. That's probably going to involve a rewrite to provide background and commentary in support of the specification. So kind of just giving that a little bit of a lift to the spec. We're doing some current ongoing research addressing formwork pressures, both conventional and SCC. This is really speculative, but hopefully the eventual adoption into our spec would be the results of that research. And then, I guess my other point there is just that, if we can maintain progress in the specification and make sure that our document remains relevant and effective. And then the last thing is SP4. That's going to continue to be a document we want to support. So that's going to be, is in need of a rewrite anyway. It's going to get rewritten to be in line with the specification. Maybe not this next one, but eventually. And then I don't know how many of you know, but yeah, ACI 318 is the largest bestseller for ACI SP4 is the second bestseller in ACI's history. So it's kind of a fun fact. And that is that. So, thank you for your time.